Good evening, everyone. Now we will start our class today. I'll switch to the screen. Yeah, now we come to screen. Let's see, we should. Maybe I will put them in the. I think I should put them in the team talk because ends the camera and come back to camera and the camera and start it and put it into a course. Put the course get files. Today's 5 and 6. The assignment. Assignment is 4. Okay. And I open it. There's 5. Okay, it's good. So I think it's more convenient for us to use this software to make the class, because today we don't use the Blackboard anymore. Instead, I bring my touchpad, so I only focus on the screen. Now we will share the screen, and all of you can see the slide here. The next week, we'll learn something about the object. That is how to create an object if you have the code for a class. Based this code, we use a statement, use a keyword new to create object based on this code. And we have learned if you have own object inside memory, you must have a reference variable that is can point to this object in the memory and access it. Use this reference variable. And today we'll talk about the class and the architecture of the class. That is, what is inside the class. how to write each part inside the class body. Okay? So this is today's content about class. And I will give you an example. Now, let's say we want to create a stack. A stack is, give my pen. Stack is kind of object. I'll have a stack. It's kind of object. This kind of object has a very interesting characteristic. So that is, we put items inside the stack and we get it out. And the order we put items into a stack. For example, we put 3 items into this stack, into a structure. The first one, the second one, and the third one. The first one is a triangle. The second one is a rectangle. The third one is a circle. We put 3 items into this stack. Follow this order, 1, 2, 3. And when we get it out, the first item we put into a stack is on the bottom of the stack. And then there's a rectangle, and then there's a circle. So when we get them out, the first item we get from the stack is a circle. And the second I get from the stack is a rectangle. The last one is a triangle. So this is the features of the stack. That is, we name it as FILO. That is, first in, next out. First in, next out. So the first item we put into a stack, we get them out of stack, it becomes next one. The last item we put in the stack, we want to get it from the stack, it becomes the first one. So this the feature of the stack. The name is FILO. The FILO is the features of the stack. Now we want to create an object for the stack in our program. How to create this object? We should have a class, because as we know, if we want to get an object, we must write a class, and then we use new keyword to create the object. So we must write the code for the stack. Here's the structure of the class. Here's a class diagram. As we know, it's a UML diagram. Class diagram. Stack is the name of the class. And then this the items. The items is the variable of the stack. What it's used for? What we use the item for? The items is a reference variable that point to a special structure, vector. Okay. As we know, we want to create a stack. And inside the stack, we must have a container to put all these items, this triangle, this rectangle, circle, all kinds of objects, items into it. So we must have a container. How to create this kind of container? We don't need write the structure ourselves, because in the API, the Java platform have already give us a container, a structure. The name is vector. So we simply use this vector. So we add the reference variable into the stack, and its type is vector. That means inside our stack, we must create a vector. that it will be used as a container, and that will be used to store all these items that we want to put into the stack. So we have a vector, this variable. And then we define the method for the stack. We define three methods here: the push, the pop, and its empty. The push method is we put items into this stack. We use push method. And pop method, if there's some items already existed inside the stack, want to get them out, so we use pop method to get items from the stack, take the item out of the stack. And this empty method is a method we use to check, is there any items inside the stack? If it's empty, no items inside the stack, this method will return true. That is, there's nothing inside the stack. But if it returns false, that means there's some items that inside the stack. So we define a method, it's empty, to check is it empty or not for our stack. So we define three methods in our stack class and define one reference variable items for our stack. So this is class diagram. Before we write the actual code for the class, I strongly recommend all of you to draw this kind of diagram to describe what inside your class. Then you can write the code for the class. So we write the code for the class. And we can write the code, use IDE. For example, we launch IDE NetBeans and write code for the stack. And here's my code. I have already created a project and write a stack class inside it. Here's the class. The class name is stack. So the structure is, if we want to create a class, we should use a keyword class. And we have give the class name. Class name stack, remember, when we write a class name, we should name it as the upper camel case rule. We should obey the upper camel rule. Oh no, right, the backward. Upper camel rule means if this name we have more than one word for the name. For example, it's my stack. If its name is my stack, what we should name it? That is my STC stack. And the upper camel case rule is the first letter of the word. We should make it big. So we write the name as big M, small y, big S, small t, a, c, and k. That is upper camel case rule when we write the name for the class. Here, because we only have one word for the stack, on the stack, so only one word here, so the first letter we make it as big S. So in the future, when you write a class, you obey the rule that make the first letter the big letter. It is very important because in the future, if you have become a programmer in a company, you should obey the rule. All this code that you write for software should obey a lot of documentation or coding rules. The upper camel case is one of them. How to name the class. And if you want to name a variable inside of class, you should obey, or method, you should obey the lower camel case. The lower camel case we will talk about later. So inside the stack, this is class, we have a brace. And inside the brace, we will define the variable and method. The variable is a reference variable. The name is items. And this type is vector because we will use the vector, the kind of class applied by the API of Java platform. It will become a container that will put items, actual items into a vector. So we define a vector, the type for storing all these items inside a stack. So we define a vector, the type of a vector, a reference variable here. And then we define several methods inside the class. Here we have three. Now we define three methods here. The first one is stack. It's a constructor. The next one is still a constructor, and the next one is get capacity. Get capacity is get the size of the container. So we define three methods inside the class. So that is the structure for a class. So remember, if we want to define class, we should use the name keyword as class and give this name. And inside the brace, inside brace we name as class body. Inside the class body, we should have variables and methods. Depending on what we want to do, here we define only one variable here as a vector and define three methods inside this class, two constructors and one member variable, a member method, get capacity. So that is how to define a class. And back to our slides. Slide is here. Oh yeah, it's inside. Now we will talk about the modifiers for the class. Before the keyword class, we can add some modifiers here as public, abstract, final. If we mark a class as public, means this class is publicly accessible. It can be accessed out of the package. We will talk about the concept package, this concept later. So if you want to, this class is publicly accessible, especially when you write a project. Inside a project, you have, for example, you have inside project you have three classes. Each class you put it into a source code, and you must make one of these class as public class. And inside the public class, you define the main method. So it's an engine for the JVM because when the JVM, as we know, the Java bytecode cannot run directly on the operating system. We must have a JVM as a platform. So the JVM will know your class, your bytecode, and how the JVM find your code, find the first statement that can execute. So the JVM will find the class that mark it as public. The first step is find if you have a lot of class inside the project, inside the software, but one of them is public. So the JVM will find this public class. This is the first step. When we find the public class, then it will find if there is a main method inside of the class. If we find a main method, so it will execute the statements you have written inside this main method. So that is very important because in the future, when you create a project, in general, we will put each class into a standalone source code, and if you have 3 class, so we have 3 source code, 3 Java file, but you must mark one of them as a public class. And inside the public class, you put the main method. So inside the project, you have lots of classes, but only one classes should be public. And inside the public class, you will put the main method. So you only have one main method inside the project, and the main method is put into the public class. So this public is modified. And the abstract, when we mark as a class as abstract, so the class become abstract class. We'll talk about later. And the final, the class will become a final class that cannot be subclasses anymore. So this 3 modifiers we can put before the keyword class. So the name of class, as we know, we should obey the upper camel case rule to write the name, give the name of class. And after name of class, if your class is a subclass of some superclass, so we should use extend this keyword to describe the inheritance relationship between the superclass and your class, because your class is a subclass. So use extend keyword to describe this relationship. And if your class will implement some kind of interface, we will talk interface later. So we use a keyword implement to describe this interface implementation. So that's the keyword, the modified these words we can put before the name of class and after name of class. And inside the brace is a class body. So this is how to declare a class. And inside the class, we have variables and methods. And the variable, as we know, have 2 kinds of variable. One is primitive type. For example, the int, the character, the boolean. These are all primitive type of variable. And another kind of variable is reference variable. So the type of the 2 kinds of type, the primitive type or the reference type. And then they give the name. The name of variable, if you name a variable, we should use the null camel case to define a variable. That means we have more than 1 word for the variable. Each word, the first letter, the first letter of the first word, you should make it as small letter. But from the second words, all these words, the first letter you should make it big. So it's a little bit different from the upper camel case rule. When we name the class, we give a name class, all these words, all these first letter of the words should be big letter. But the null camel case, only the first word, its first letter is small letter, but the other words as a first letter should be the big. So this the null camel case rule when we name the name of variable or the methods. And before the type of variable, we can give this modifiers as access level, as private, default, protected, public. We'll discuss later. And static. Static, if we mark a variable as static, means this variable become a class member. We'll talk about later. And the final, this variable become a constant. And transient, wallet. We will talk about them in the future. That is how to declare member variables. For example, in our stack. Come back to our stack. In our stack, here is the name of the variable. Because we have a reference variable. Its type is vector. So the vector, it is type. items is its name, the variable's name, and the private is access level. The access level is private means these items, this variable only a variable to access, allowed to access inside the class. Out of the class, nobody can access the items. That is the private, this access level mean. The more information about this access level, we will give you more information in this chapter later. So this is the modifiers we can add before a variable, and the next is the method. How to define a method inside the class body? It is similar as the C language. We declare a function. We define a function in C language. It is the same. So we have this kind of parts for a method. The method name. So the method name should, if you give the name for the method, you should obey the lower camel case rule. That means, for example, here's the example. Method name. We have two words for the name. The first word method, the first letter for it, we make it small m. But the second word name, this first letter, we make it big. So it's we name it no camel case rule when we write the name of for class. So this is class name, and we have a parameter. Inside the parentheses is lots of parameters. So we have a parameter list inside the parentheses, and methods should have a return type. So we have a return type. If not returned, just like C language, we write void, this word here. But if there's any kind of return value, we should put suitable type here, return type. This is method, how to define the method. So if we come here, we will see this example. Now, we define the method as get capacity. So the get capacity is the name of the method. The name, we write the name, we use this lower camel case rule. That is, we have two words here, get and capacity. And the two words, the first word, we should make the first letter of the first word as small letter. So we have small g, E, T. And the second word, the first letter for the second word should make it big. So a big C, capacity. So this is the rule for naming this method. So you use the lower camel case rule. But if we define a name for a class, because for example here the stack, this name of class, we should use this upper camel case rule. Upper camel case, so the first letter for the first word should be the big S. So why we name it as camel case, upper camel case or lower camel case? Because as you know, the animal, the camel, on the back we have this, the camel case. So camel case is up and down. So the upper camel case and lower camel case is just the animal, the back of the camel. So we give its name, upper camel case and lower camel case. The upper camel case rule for naming the class. The lower camel case rule for naming the members inside the class. So this is the name of the method. And inside, after this name, it's the parameter list. So we have a parenthesis, but capacity, this method, we don't have any parameters for it. So inside the parenthesis, nothing inside it. And the left side, before the capacity, the name is a return type. Because we get capacity, this method should return the capacity of this stack for me. So we define an int value, primitive type value here. So the int is a return type. And now we have the brace. Inside the brace is how to implement this getCapacity method. GetCapacity method, we use a return statement. And return statement, here we put items capacity. Items is our vector inside the stack, because items is a vector. That vector is the object provided by the JVM, by platform. So the vector has lots of methods that we can use. One of the methods is capacity. It can give us the capacity of the vector. So items capacity will return the capacity of the items of the vector, and it's an int value, so we return it as an int value. So return type is int. So this is how to define a method inside the class. But we have two other methods inside the class. Its name is the same as the class name. The all stack. The name is same as the class name. And these two methods do not have return value. It's not void, it's not any other return value, no return value here. So this method we name as constructor. In the next chapter, we talk about how to create an object. We have this idea of constructor. This constructor can execute it. When you create object, it will execute it and it will initialize some kinds of value inside your class. So here the step is the method. We use the step method, this constructor, to initialize our stack. Because our stack, what we should initialize, we should customize its capacity. We have the stack. The capacity of the stack is allow us to customize it. So we use the constructor customize the capacity of the stack. How to make this capacity of this container, because the container is a vector. So we use vector. We create a vector object. We new vector. So here we get a vector object, and as items which you put inside the stack, actually they are put into this vector content container. So new vector term means the capacity of this vector can allow us to put 10 items inside it. So the capacity of a stack is the same. We can put 10 items inside our stack, the same. And we write another stack here. Another stack, notice that this stack we have a parameter. But the first constructor, the parameter size is empty. But the next stack inside the parameter size, we have the value. We have the argument. The argument is the name. It's the size, it's the capacity of these items, of this vector that we want to customize there. So if we want to customize the size, the capacity of the stack as, for example, as 5, so we will pass 5 as argument to this parameter. So the items here will new vector 5. So we have a vector that allows us to put 5 items into it. So our stack is a same. We only allow to store less than 5 items inside our stack. That is this construct mean. So we have two stack, two constructor inside one class. We will name it as overloading. This is overloading. We'll talk about later. Overloading. We have two methods inside two same methods have the same name inside one class. That is overloading. Okay, we'll talk about later. So that is for how to define the members, the variables, the methods into a class. Okay. Whoa. Come back. So before the return type of class, it also allows to access lots of modifiers. The access level is the same as for the members, for the member variables, static that make a class, make a method become a class method. If I add the abstract, it makes the method become an abstract method. That means we don't need to write an actual code for this method because it's not implemented. The final, the method cannot be overridden. And native synchronized, we'll talk about it later. And we can add those exception statements after the parameter list. We'll talk about in the 7th chapter, exceptions. What it means, we'll talk about later. So it's how to define a method inside the what it means, and then you can learn how to use them. So do not remember anything. When you learn a programming language, do not remember anything. You don't remember, you should put this word inside the method. You don't need. If you can remember them, you can find the slides, find a book, and you can get it in. So do not remember them. It's very important. And only focus on how to use them, how to understand them. And if you want to understand them, the best way is write code and practice. Write code and write code and use these words, use these keywords, use this methods definition, and this practice will make you understand them deeply. So this is a very important way to learn for a programming language. This is how to define method. Well, the next thing I want to talk about is the overloading. At this code, we have two methods. They have same name, the all stack, and they have same name, but the difference is the parameters are not the same. So this, something right, wrong. So here, something wrong. Don't need. Here's the share screen. So this we name as overloading. Overloading means that we can define more than one method inside our class. They are all have the same name. They share the same name, but the difference is the number and the type of arguments of this method are not the same. For example, in our class stack, we have two constructors. The two constructors are two methods. They have the same name, but the argument is not the same. The first step, we don't have any parameter, but the second one, we have one parameter. So the number of the parameters is not the same. This is what we call it overloading. Okay. So we'll have a short break. Okay. 5 minutes later, we'll come back to our class. Go. So now I want to make a roll call for our students inside the classroom. So I will read the student number, and if you are here, please raise your hand. Okay? What is it? We only read the last three, not three digits. 102.
Yeah, 102.
Yes, 102. 102. And 105. Okay. And 106. And 108. 108. Not here. And 112. 112. 112. 112. 112. Yours. 112. Okay. Then 122. Double two. 122. You're not here. And 125. Yeah, 125. And 127. 127. Okay. And 128. 128. 128. Anyone else? 128, the number? And 133. Okay. So 1, 2, 3, 4, 5, 6, 8. What is the number? 1 to 8. 1 to 8. Oh, 1 to 8. Okay. So only 8 students inside the pattern. And how about the rest of 2 students? Are those still inside the campus? Yeah, but they don't come here. 1 or 2 students are not here. Where are they?
They're probably sick.
Sick. Oh, one of them sick.
Yeah, only sick.
Still making. But if it's sick, he should have excuse sheet for me, so I know his shit. So next time, if he come here, if it's feel good, and you can come here to the class, and you please talk for him to bring an excuse sheet for me, okay? And yeah, so that I will make it marked as sick. It's not as absent. Thank you. screen sharing. Wow. Watch your live and give me a like. Give me a like. Well, how to give you a like? I don't know. We come to like. And give a like. Or give a like. Oh, yes. Thank you. Or we have 8 students online. We have 8 students in person. So we have 16 students for course, but we have still have half of the class, half of students. I don't know where are they. It's a problem.
Yeah, it's it's like French choice recipe.
Well, let's go back to our class. And we come back to this slide. And we are talking this overloading. Well, overloading means inside a class, you have more than one method that have the same name, but with a different parameter. So we name it now we have a class. We define it data artist. Inside the artist, inside the class, we define 3 methods. Draw. They have the same name, draw, but different parameter. The first parameter is string type. The second one and the third one is primitive type. One is int, another one is float. So the draw, this method is overloaded. Overloaded means if we want to give different versions for a method, you can use this overloading rule. That is, in the future, if we want to use one of them, how you should do, you should use a different kind of argument to pass them to this method and decide which version you will use. For example, we have this class data artist, and once we have the class, we can create an object. For example, we create object for the data artist as here's a data artist. We have this class. So we define a reference variable. Its name is DA. The type is data artist. And as we know, we write a statement to create object, new keyword, and the name of the artist. It's a class name. So now, when we execute this statement, we get an object inside of memory, and we have the reference variable DA to access this object. And once we get the DA, this reference variable, we can access object inside the memory. So we can use this member method inside this object. That is draw, because we only have one kind of method inside the artist. Although we have 3 different versions. So how to use the different version? Use one of the version for this draw. If you use DA dot, we know with qualified name, DA dot access the members inside the object. DA dot draw. If we give this argument as a string, for example, we put a hello, all these letters, we put it then inside the double quotation mark, the string. If we use this DA.draw argument is a string that we will use this version of draw method. And if we want to use another version for this method, for example, we write a 10. So it's an integer. So we will match this version, draw int, so we use this version. Because this method, the 3 methods, although they have the same name, but they have different argument, and they have different implementation. So inside this implementation, this method body, they have different kind of code. So we use the argument, different argument to pass as into the method to use a different version of this method. So this is how the overloading works. So we define different version inside the class with the same name but different argument list. In the future, when you have an object, you can use one of them. Depending on the arguments, different arguments, we will use the different version of this overloading method inside your class. That is overloading. So next, we will talk about how to pass information into method. How to pass information to a method, because when we define method, we have argument list. So we will pass information through these arguments to the method. So, but we have different kind of arguments. One is the primitive type of value. Another one is reference variable. So how the difference is, we will see some example for it. For example, if we pass a parameter data type, a value to a method, for example, we define a method as compute payment, and we inside the parenthesize it is argument parameter list. We have 4 arguments. They are all primitive type of value, 4 arguments. And if we want to use this method, we will use the compute payment, and we pass the actual number to it. The 3 double 1 int, 3 double 3 double 3 double, and 1 int value. We pass 4 arguments to this method. And remember, if we pass this 4 value to this method, and inside the method, the statements, the expression will use the value you passed through the argument. For example, now we pass the read, the double read, this value to it. So inside this method, in the expression, we will use the read, and the real rate divide 100 and get a result. So the value rate is coming from the argument. That is the same as the C language. In C language, we name it passing value to a method. So now it's passing value through the argument. It's quite simple for you because you have learned something about it in C language. There's a lot of similarity between the Java and the C language because the Java is developed, designed based on the C and C++ language. So its grammar has a lot of similarity, but they have difference. And another one type of arguments is reference value. So the reference data type. For example, now we have this method, polygon from. It's polygon from, and the polygon from inside its argument. Here we notice it's array. Now we have array as its argument. The point is array because now we have a square brackets here, so it's array. So list of points is the name of the array. So we will pass an array object to the polygon from method. What does it mean? Now we want to create a polygon. How to create a polygon? For example, we have the triangle or the rectangle are all polygons. The triangle has a rectangle. We should have 4 points to pass to the polygon from. So that's the idea. So before we create a polygon, we will create an array for points. So we will do the job. So we define a point, a class. A point class, inside the class we have 2 variables. The position of the point inside the coordinate system, the x and y. In the coordinate system, we have point, we have position, x and y. This is point. We define an object.